Fire trucks are some of the most complex, specialized, and purpose-built emergency vehicles in the world, combining heavy-duty engineering, extreme reliability, powerful pumps, high-pressure water systems, advanced electronics, rescue tools, and life-saving equipment. Yet most people never witness the enormous manufacturing process behind them. And today, on the How Factory, we're going deep inside the factories, where bare steel chassis are transformed into fully operational fire trucks that rush into burning buildings, rescue trapped victims, and respond to critical emergencies every day. The journey begins with the chassis, the foundation of the truck, which often arrives from commercial truck manufacturers as nothing more than a reinforced frame with wheels, axles, an engine, suspension, and a cab shell. Fire truck builders receive these chassis as blank platforms, and from this point onward, everything becomes highly customized. In enormous assembly halls, engineers inspect the chassis, confirming structural integrity, alignment, and load-bearing capability. Fire trucks must withstand enormous stresses: heavy water tanks, ladders, pumps, rescue tools, and rapid acceleration during emergencies. Once inspected, technicians begin routing thousands of feet of wiring, hydraulic lines, brake hoses, air lines, and communication cables throughout the chassis. This wiring harness acts as the nervous system of the truck, connecting lights, sirens, radios, pump controls, sensors, cameras, and emergency communication equipment. The electrical system is designed with redundancy, so life-saving components remain operational even if one circuit fails. Next, attention turns to the construction of the body. The massive aluminum or stainless steel compartments that store gear like hoses, axes, breathing apparatus, ladders, medical equipment, and cutting tools. Sheets of metal are cut by CNC lasers into precise shapes, then bent and formed into panels using hydraulic press brakes. Welders assemble these panels into large reinforced storage compartments. Some factories use robotics to ensure perfect weld consistency, while others rely on master welders with decades of experience. Every compartment is designed for maximum durability and weather resistance, because fire crews operate in rain, heat, snow, and extreme temperatures. After the body framework is completed, it is mounted onto the chassis using heavy-duty bolts and brackets, engineered to withstand vibration, speed, and the stress of sharp turns while loaded with equipment. Meanwhile, in another part of the factory, fabrication teams build the pump house, a structural module that holds the heart of the fire truck: the pump. Fire pumps are precision-machined machines capable of moving thousands of liters of water per minute. Engineers install stainless steel manifolds, valves, intake and discharge ports, pressure regulators, flow meters, and control panels. Before installation, each pump undergoes pressure testing using high-volume water systems to verify no leaks, failures, or mechanical defects exist. Now comes one of the most important stages: installing the water tank. Most fire trucks carry between 500 and 1,500 gallons of water, and these tanks are made from polypropylene or aluminum to prevent corrosion and reduce weight. Tanks are welded or heat-fused together, then pressure tested with water to ensure they are completely sealed. Once approved, cranes lift the tank into the truck's body, where it is bolted into place and connected to the pump system through large-diameter piping. At the same time, ladder racks and hose beds are built. The hose bed, located at the rear, is engineered to hold hundreds of feet of heavy hose in an organized way that firefighters can deploy instantly. Pneumatic or electric hose lifts may be added for easy access. Concurrently, technicians install powerful engines, often diesel engines producing 350 to 600 horsepower, that must provide both vehicle propulsion and pump operation through a power takeoff system. The truck's cooling system, batteries, alternators, air systems, and fuel lines are finalized and tested under load. As assembly continues, technicians begin installing emergency lighting and sirens. LED light bars, perimeter lights, floodlights, and directional warning lights are mounted around the truck to ensure full visibility during nighttime operations or emergency responses. Sirens, mechanical, electronic, and air horns are wired into the electrical system and tested to meet local regulations. Meanwhile, the cab interior is customized with rugged seats, safety harnesses, self-contained breathing apparatus mounts, storage drawers, digital displays, radios, thermal imaging camera docks, and crew communication systems. Everything inside the cab must withstand heat, vibration, moisture, and the demands of rapid deployment. Next, attention shifts to finishing the truck body. Panels are sanded, cleaned, and moved to the paint facility. Fire truck paint jobs are engineered for durability and visibility. The truck is primed, often with corrosion-resistant coatings, then sprayed with vibrant colors, typically red, yellow, or lime green, using electrostatic or high-volume paint systems. Reflective striping and chevrons are applied to increase nighttime visibility. After curing, the painted body returns to the main line for fitting of diamond plate steps, handrails, grab bars, storage door frames, roll-up compartment doors, and rescue tool mounts. Roll-up doors, made from interlocking aluminum slats, provide fast access to equipment while staying durable under rough use. At this stage, the truck finally begins to look like a fire engine, but much remains to be done. The pump control panel, a complex dashboard of gauges, touchscreens, levers, valves, and sensors, is wired and tested. This panel allows firefighters to control water pressure, monitor intake, switch lines, operate foam systems, and adjust flow rates during active emergencies. Engineers test every function under simulated firefighting scenarios, pumping thousands of gallons per minute to validate performance. Foam systems used for industrial fires, chaquipas, are calibrated, with tanks of foam concentrate installed and connected to proportioning systems that mix foam with water at exact ratios. The truck's onboard air system is connected to the SCBA bottle refill station, allowing firefighters to pressurize breathing tanks directly from the truck. Now comes installation of exterior equipment, including ladders, axes, pry bars, Halligan tools, chainsaws, ventilation fans, medical kits, defibrillators, trauma bags, thermal imaging cameras, and hydraulic rescue tools like the Jaws of Life. Many fire trucks feature slide-out toolboards, custom racks, and cable-powered shelves that bring heavy equipment to waist height for safer access. Some trucks include high-powered generators, scene lighting towers that telescope upward, and long-reach deck guns capable of projecting water hundreds of feet. Next, the truck undergoes electrical testing. Hundreds of circuits are checked for continuity, amperage, load capacity, and fault resistance. The truck is connected to diagnostic software that verifies every sensor, switch, and control unit is functioning perfectly. Afterward, technicians begin installing communication equipment, including radios, GPS, onboard computers, antenna systems, cellular routers, and dispatch consoles. These integrations ensure the truck stays connected with command centers during emergencies. When mechanical and electrical installation is complete, the truck moves to pump testing. This is one of the most dramatic stages of the build. The fire truck is positioned at a pump test pit, a large water reservoir with recirculating capacity. The pump is engaged, drawing thousands of gallons of water through test hoses at multiple pressures. Operators record flow rates, pressure stability, pump temperature, valve operation, foam system activation, and the truck's ability to maintain consistent performance over time. If the pump fails any test, engineers return it to the assembly area for adjustments. Once the pump passes inspection, road testing begins. A test driver takes the fire truck onto a dedicated track to evaluate steering, braking, acceleration, noise levels, suspension response, turning radius, and cab comfort. Emergency lighting and sirens are tested at road speeds. Air brakes are checked under load, and the truck's ability to handle full water weight is assessed. If it is an aerial ladder truck, the ladder undergoes extension and weight testing. Outriggers deploy to stabilize the vehicle, and the ladder is elevated and rotated to ensure full structural strength. Load sensors, hydraulic cylinders, and safety interlocks are calibrated to prevent accidents during high-angle rescue operations. When the truck passes all mechanical, electrical, pump, and road tests, it enters final quality inspection. Inspectors verify welds, seals, fasteners, panel alignment, compartment operation, and wiring management. Every piece of equipment is checked against customer specification sheets. Only when everything is perfect does the truck move to cleaning and finishing. Protective films are removed, stainless steel parts are polished, windows cleaned, tires dressed, and compartments vacuumed. Finally, the fire truck is ready for delivery. Firefighters from the purchasing department arrive to receive hands-on training from factory specialists. They learn how to operate the pump panel, manage foam systems, deploy ladders, run the generator, use the tool mounts, and maintain the truck properly. The delivery event often includes live pump demonstrations and equipment walkthroughs. Once complete, the fire truck is loaded onto a heavy haul trailer or driven directly to its new fire station, where it is equipped with department-specific gear and placed into service, ready to respond to emergencies at a moment's notice. Behind every fire truck lies an incredible combination of heavy engineering, firefighting science, robotics, computer-controlled machining, aluminum fabrication, hydraulic systems, electronics integration, safety testing, and human craftsmanship. And that is exactly how fire trucks are built, from bare chassis to life-saving machines. A stunning blend of precision, strength, reliability, and innovation, powering one of the most important emergency tools in the modern world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us for more deep dives into the systems behind everyday products.